okay? Remind me to turn that off if you do any temporary. All right? But we'll start with one we know, which is the first one. So go ahead and do the first one. Inverse cosine of cosine of 7 pi over 6. That's, we could have had that on yesterday's lesson. All right, we know it's not 7 pi over 6 because 7 pi over 6 is in the third quadrant. So what should it be? Pi over 6, 5 pi over 6, or negative pi over 6? Those are your choices. What do you think, Lindsay? Pi over 6? Because cosine is negative over here. So we want to do, it won't be pi over 6 because cosine is a negative in the. Okay, this right here has a negative value, correct? Okay, so we have to figure out the angle that will give us a negative cosine, which would be the second quadrant or the fourth quadrant. Second. So 5 pi over 6.
Because cosine would be.
Remember, cosine is the weird one where we are here for positive cosine and here for negative cosine. Because remember, all students take calculus, the cosine is positive here, so that's why we got to move to different quadrants. Yes.
We can change it if like if it's like a really big number, like also more than one.
Yes. Yes. Good question. Yes. Yes. If it's like a big number, even though it falls in the same place, we need to make it to the small number. Because remember, we are only supposed to be, well, for cosine, we're only supposed to be between 0 and, sorry, this is your theta, 0 and pi. You know, what is one, like 7 pi over 4? Is that around, no, 9 pi over 4. That will land in what quadrant? It'll land in the first quadrant, but it's not in this range. So we wouldn't want to call that. We want to call this. That's an excellent question, Karen. Yes.
Well, so you know how we were talking about cycles a while ago? That
yes.
Like 7 pi over 6 is the same thing as pi over 6. That's not a pi
So
here.
7 pi over 6 is not the same thing as pi over 6.
I feel like I remember doing that. Only pi over 6.
Maybe that's what you're thinking. You're going all the way around and then
Yeah.
All right, now, notice what's different about these two guys here. They're still composite functions, but what happened? Right, the functions are different, so we have to treat them a little bit different because we're no longer using this property or this one. Those aren't going to be applied, okay, because we have two different functions. All right, so we're still going to kind of graph it. So it's still going to be kind of a process to get there. Where do I find the, remember this inverse tangent of 3/4 means the tangent of some angle is 3/4, right? Okay, so that's definitely a positive tangent value. Where's it going to be? First quadrant. We remember our two choices are first for tangent and inverse tangent, first and fourth. So it's first. Okay, so we're going back to SOHCAHTOA. TOA. Opposite hypotenuse. So my 3 goes here, my 4 goes there. Okay? So far so good. What's the hypotenuse, just in case I might need it? It's a 5. That's right. That's that triple 3, 4, 5. Okay? So what's the cosine of whatever angle that is? I don't really care. I could call theta right now, or alpha, okay? What is the cosine of that angle? 4/5, and I'm done with it. Okay? So I gotta put it in the right quadrant. That was kind of a little bit. Did I see for a few of you on the test, you weren't putting them in the quadrants, you're just kind of doing them, even though I told you a quadrant. Okay, for the most part, you did right, but that is imperative because that will give you the, first of all, give you, you'll be able to figure out the other length, you'll be able to use the SOHCAHTOA, and you'll be able to figure out the negatives and positives. All right, so let's do this one. It's very similar. This is some angle right here that has, what do we know about that angle in that parentheses? Sine is negative. Okay, so remember our two choices for sine are first and fourth. Okay, which one are we in? Fourth, okay? So here we are. We can call that whatever we want to call it. So let's call it x. Okay? So the tangent of x, well, I know my sine is opposite over hypotenuse. Hypotenuse is always positive. That's how I knew the -2 had to be down. Plus, I can see I got to go down to get to that triangle. What's this side? Because I think we're going to need that for tangent. Square root of 21. Nice. Do the Pythagorean theorem there. So what's the tangent of x? -2 over square root of 21, which is over 21. Yes. Because it's this 5 squared equals 2 squared plus whatever that is squared. So that's 25 minus 4. Okay. Did you do it like you squared these two and added them? Yeah. It's, remember, sine is so opposite over hypotenuse. Okay. So if you put it in the right quadrant, the negative will take care of itself. But remember, the hypotenuse is never negative. The legs are, but not the hypotenuse. Remember, that's the unit circle. If you want to think of it as a radius, you can have a negative radius. Okay. Any questions on that? All right. Now, this is the inverse secant function. It's basically, secant is the inverse, the reciprocal of what? Cosine. Okay? So whatever applies for cosine also applies for secant. So here's your secant function. We're going to narrow in on 0 to pi. So this is the secant function. If we just take that, flip it around for your inverse, that's that and that. Do not worry about doing any graphing. Yes?
So this would also be an
Technically, yes.
But it would be
yes. Yeah, there's a horizontal asymptote at pi over 2. But again, you're not going to have to graph them. You just have to be able to manipulate. You have to know this. Okay, and that might come up, but not very often. And then, of course, you are in between, whatever. I think you're going to be good. Let's go on and mess with cosecant. Remember, cosecant is the reciprocal of, which one? Sine. Okay, so again, we're back to that negative pi over 2 to pi over 2, which is that fourth and first quadrant, okay, which is nice. And then it looks kind of like the same. That's what it looks like if you were to graph it. Do not have to worry about graphing, okay? That's your secant, cosecant. All right, and then we have one more, which is the cotangent. The cotangent is the reciprocal of the tangent. So we're back to that. Notice that less than or equal guys are gone because we have, that's where those original asymptotes are. Again, you'll get it. But it's that, for that again, just like tangent, okay? And you don't have to worry about inverse cotangent.
We don't have to worry about the undefined business really for X. Okay, like we do with all the rest of them. Okay, let's try some. All right, I'm kind of thinking that these will be, you'll know what to do. There is an inverse function. Sometimes it gets lost on these little problems. I don't know why. Okay, so who thinks they would know what to do to find the inverse cosecant of that thing right there? Naomi?
Since you know that it's the inverse of sine, could you say that it could be hypotenuse over opposite? Or could
We
you-
are, okay, first of all, if we're looking for exact, we are going to be on the unit circle. Okay? So, we don't have to go the route with the composite functions that we just did. So, if that's what you're thinking. What do you think we're going to do?
Is that be enough work for
Okay.
it?
Okay, but we need more details in the fourth quadrant. I thought this would be more inherent. Okay, what about if I change this to inverse sine? Would that be good? Because cosecant and sine are reciprocals, right? If I change that, then what does this get to change to? Okay. Now, do you recognize that one? Not really. That's a good question. I mean, that's a good answer. Honestly, I was waiting for that answer. But we're going to fix it so that you do. And what is that? Negative 3 radical 3 over 2 times 3. 3's are canceled. Now, do you recognize it? Yes, thank you. Negative radical 3 over 2. Okay? Sorry. I'm squeezing. Okay? But you don't recognize it because it's not in a good form. But so we had to switch to get this. We switch it to the reciprocal function. So we switch this to the reciprocal as well, and then finish it so that we can recognize it. Now, what is the inverse of negative radical 3 over 2? Pi over 3 or pi over 6? Sure?
Yes.
And it's negative.
Negative.
It's negative pi over 3.
That is close.
Okay? So you got the pi over 3, but then you have to put it in the fourth quadrant, so, because that's what inverse sine does, and cosecant. Now, you couldn't put that in the calculator like that. You'd have to put it in the calculator like this if you were going to do the calculator. Okay, so if I was going to do the calculator, but I'm not, what do I change secant to? Inverse cosine, okay? And what do I change 2 radical 3 over 3 to? 3 over 2 radical 3, okay? I hope that makes sense. If you change the function to its reciprocal, you need to change the number to its reciprocal, and then everything is good. All right, now fix it. What is that really? I think we just had one like that. So what is that? Radical 3 over 2? Get rid of this. This becomes 3, 3, 3, 3. There's a radical 3 over 2. Just did it right here except with the negative. Okay? So, yikes. All right. What is the inverse cosine of radical 3 over 2? 5 or 6. We're in the first quadrant. Is that where we want to be? Okay. Okay. Unit circle value, right quadrant. That's what you have to check. When you were doing the regular trig functions, not the inverse trig functions, you had to do the same thing. You had to find the value of your 1, 2, 3, boom, 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 and then you had to figure out what quadrant it was to determine this SIGN. So it's the same idea, except a little backwards. Do you all have
question?
No, I'm just asking.
Okay. What are you gonna change this to? Tangent. Inverse tangent of reciprocal of -1 is still -1. Okay, don't say it out loud, but figure out what the inverse tangent of -1 is. Inverse tangent of -1. Make sure it's in the right quadrants. Correct. All right. Got it, Elena?
Tangents y over x. So,
Sine over cosine.
then over here.
Yeah. So where are they going to be the same that you're going to get 1 for sine over cosine? Think about these values. Start up and go up.
Y over 4.
Pi over 4? Negative pi over 4. Okay. We're a little shaky with the tangent because we don't memorize, but you still have to think, okay, these values are both the same. Your tangent, that's where your tangent is going to be 1, but you need to be in the 4th quadrant, so that's negative pi over 4. Good work. Any questions on those inverse weird functions? You need to do reciprocal functions, okay? Switch them out so that you're comfortable with them. Remember, this would have been 7-1. That's we started out before we did the composite functions. We did the inverse functions. Okay. All right. Calculator. Go ahead. Now, you are in radians. Make sure you are in radians. That's assumed unless they tell us differently. Let's just say. I'll be working. Here we go. All right. What did you actually put in your calculator for this problem, Melanie?
Inverse cosine.
Very good. Okay, now if you have it set up right, your answer should be, let's go, in radians, that'd be 1.369. Okay? You don't have to say radians because it's assumed. All right, very good, Melanie. All right, what did you put in your calculator for cosecant of -4/3, Sarah?
I put inverse sine.
Very good. Did you flip around the right thing, Karina? Or did you forget to flip? Okay, I'll come over and look at your calculator.
This works.
Okay, I'm going to scroll and see. Did you get -0.848? All right. What? Good job. What'd you put in, Claire, for the inverse cotangent? Now that's one that we could do exactly, but it doesn't say we have to, so we're not going to. 1.047. That is a unit circle value, just saying. Okay. And then inverse tangent, what you put in for this one, Lauren?
Inverse tangent.
Okay, good. All right. And that is, very good. Okay. So you gotta put those in, you gotta reciprocate both. I bet you did.
Is that your face?
What sign is it? Okay. What are you laughing about? Think about changing my hairstyle? Right? What happened? Did you get some problems on that? Let's see what happened to me.